What happens when scientists discover that life isn't just on Earth, but inside it? Not just underground caves, not just deep mines, but a vast, hidden ecosystem stretching through the planet's crust, so large it feels less like a layer of Earth and more like a second world stitched inside the first. A world we never saw coming. This is the discovery of the deep biosphere, the underground ecosystem that exists beneath our feet, where life doesn't just survive, it rewrites the rules of survival entirely. And the strangest part? We didn't even realize how big it was until recently. It turns out, beneath the oceans, beneath the continents, and beneath kilometers of rock, there is an entire hidden biosphere, an underground ecosystem so massive it feels like a planet inside a planet. We begin where all life should be obvious. The surface, soil, forests, oceans. This is the visible layer of Earth's crust. But even here, scientists found the first hint of something deeper, because below it lies the subsurface life zone, where oxygen fades, sunlight disappears, and life quietly changes its strategy. Microbes begin to dominate. Underground microorganisms survive in groundwater, feeding not on light, but on chemistry itself. This is the beginning of the microbial underworld, and we keep going deeper, into fractured rock systems, porous stone, and hidden voids inside Earth's crust. These rock fractures form a planetary network of microscopic habitats, an unseen ecosystem beneath Earth. This is deep crust biology. Here, scientists discovered deep Earth microbes surviving in complete isolation from sunlight, entire ecosystems powered by chemical reactions in rock. Some, like Desulfurides audax viator, don't rely on anything from the surface at all. They build life from sulfur, carbon, and energy released by radioactive decay inside Earth. No sunlight, no oxygen, just rock and time. As we descend further, conditions become extreme. Heat rises, pressure becomes crushing, radioactive elements like uranium and thorium continuously warm the crust. Oxygen disappears entirely. This is the domain of anaerobic organisms, life that thrives without oxygen. Hydrogen-consuming archaea emerge. Methane-eating microbes form complex biofilm communities, creating layered living structures across rock surfaces. These are not isolated beings, they are cooperative systems. Microbial consortia exchanging electrons, nutrients, and energy in complete darkness. One species produces waste, another consumes. Carbon becomes fuel. Sulfur becomes energy. Iron becomes life. A hidden economy running beneath Earth. Deeper still, we reach a world of extremes. Temperatures exceed 120 degrees Celsius. Pressures rival the deepest oceans. Salt and chemicals reach toxic levels. Radiation intensifies. Yet life continues. Inside solid rock. But rock, we discover, is not truly solid. It is fractured, porous, and filled with microscopic spaces. A vast underground habitat system stretching across continents. An unseen network of caves and microcavities filled with water and life. A hidden world beneath Earth. And it moves. Slowly, but constantly. Tectonic forces reshape the underground landscape. Rock fractures open and close. Earthquakes create new habitats and destroy others. Minerals form and dissolve. This is geological motion on a microbial scale, rock weather, where the planet itself reshapes the ecosystems within it. And in this slow-motion pressure cooker, life adapts in extraordinary ways. Some organisms enter extreme dormancy, slow metabolism organisms that consume so little energy they may barely change over thousands of years. Others form protective endospores, surviving in suspended states for geological time spans until conditions briefly improve. Here, survival is not about speed, it is about patience. But not all life waits. Some organisms actively dominate this world of darkness. Extremophiles, heat-resistant microbes, acid-resistant bacteria, salt-tolerant archaea, and radiation-resistant organisms thrive where nothing else can. Some even appear nearly indestructible, cycling between life and dormancy across unimaginable timescales. They feed on hydrogen, methane, sulfur, and iron. They turn rock into energy. They survive where even machines struggle, and yet we still barely understand them because we cannot easily reach them. Drilling deep risks contamination. Extreme pressure and heat make sampling nearly impossible. Many microbes grow so slowly that decades of observation show almost nothing. So scientists rely on genetic analysis, decoding microbial genomes to infer what they might be doing deep underground. It's like studying an invisible civilization through fragments of code. But the implications are enormous. Because if life can exist here, beneath kilometers of rock without sunlight, oxygen, or stable temperature, then what about elsewhere? This is where astrobiology enters the story. Moons like Europa and Enceladus may hide oceans beneath ice, warmed by internal heat and radiation. If Earth has a deep biosphere, then subsurface alien life is not science fiction. It is a possibility waiting to be tested. Hidden biospheres may be everywhere in the universe. So, what happens when scientists discover life deep inside Earth? They don't just find microbes, they find a second biosphere. A hidden ecosystem beneath Earth's crust, a microbial underworld older than forests, older than civilizations, possibly older than complex life itself. A world that never needed sunlight to exist, a world that changes how we define life entirely. And as we learn more, one thing becomes clear. Life is not fragile, it is persistent. It adapts, it survives, even inside stone. Even under crushing worlds of rock and time, even in places we once thought were completely empty. If you like this kind of content, do us a favor, like the video, subscribe, and share it with someone who loves science and mysteries of the universe. It helps the channel grow and lets us keep exploring these hidden worlds together.